All right, the matrix question from 2021 then, step two paper, was this. It was question number 7. Let's go into it. So matrix R is an anti-clockwise rotation, so we should know anti-clockwise rotation is this idea, angle theta, phi, I guess. And now when we do R plus 1, or R plus I should say, now remember I is 1, 0, 0, 1. So when you add that to this matrix, you only add ones to the diagonal, the leading diagonal here, because it's 1, 0, 0, 1. You don't add anything to these two terms. So we end up with this. Now that still has to apparently be a rotation. So it still has to be something like this, the classic anti-clockwise rotation. So therefore, cos phi plus 1, we could write is cos theta. This thing here must be representing some other number that rotates. And likewise, sine phi must equal sine theta. And now we can combine these to eliminate the theta essentially, and eliminate one of cos or sine, to end up with an equation just in terms of cos or sine and just one of the two angles, preferably phi, since that's what we're going to have to find. So okay, I just squared this. There's probably much faster ways of doing this, but I couldn't be bothered to think about it too much. I just squared this, wrote it as 1 minus cos squared. This, of course, is 1 minus cos squared of phi. But of course, cos squared of theta is this thing squared as well. So now we can square this out. The minus cos squared phi will cancel with this minus cos squared phi. The minus 1 at the end of this, because of the minus there, will cancel with that. So you'll end up with 1 equals minus 2 cos phi, which is cos phi is minus a half. And this is in degrees, apparently. So when is cos minus a half? Well, you go down, you pass 90 degrees, another 30 degrees gets you there, so 120. And then, of course, go back up to 270 is the next time you're at 0. So backwards another 30 gets you to 240. I'm just always picturing the graph in my head. Find some way of being happy with that yourself. Anyway, deduce that r cubed is I. Well, okay, if R is a matrix that rotates 120 degrees, if you do that 3 times, you're going to go back to where you started. And if you rotate 240 degrees 3 times, 240, 480, 720, you back where you started, because that's 2 lots of 360. So just something like that, I think, will be enough to say it. Question, or part 2, I should say, S cubed is I, but S isn't equal to I. Show that the determinant of S is 1. So, okay, S is this matrix here. I guess I don't need to know that yet. What I'll say is, and this came up on the previous question from the 2020 paper as well. This fact seems to be something that they just want you to know, and you can use it without proof. Although in the previous question I was asked to sort of derive it, I think, if I remember correctly. But yeah, this is a really interesting and really nice fact to know. So what we'll say is, well, the determinant of S cubed is the determinant of S all cubed, but also S cubed is I. So the determinant of I is just 1, obviously. So therefore 1 is the determinant of S all cubed, and you cube root both sides, and you get the determinant of S is also 1. So okay, given that S is this thing, fine, show this thing is true. So obviously we're going to use this at some point, because step questions don't just ask you to do stuff for fun. It is fun, but that's not why we do it. We do it because it's going to be helpful for this bit here. So just in the back of your mind, knowing that this is going to turn up probably somewhere. So S squared, again, in the 2020 question, I was asked to do S squared of this exact matrix. So it's just this. I wrote it in this useful factorized form because that was helpful last time, and I can already see A plus D is turning up again. So maybe that's another thing along with this, if you're planning to do the matrix question, to just know. But in any case, we've got S squared here. Now, I'm just going to try and reverse engineer this business here. So there's a takeaway I at the end. So if I just add 1 to the leading diagonals, I can take away I afterwards, and this is all fine. So okay, we get this. And then, where do we go from here? How do we factorize out an A plus D from this thing here and just leave behind an S? How are we going to get rid of these 1s and this BC and this BC? Remember, step asks you to do this. Det of S is 1. Determinant of S is AD minus BC. There's a BC, there's a 1. That could be very useful, couldn't it? So either here you can write that 1 plus BC is AD, or you could do some black pen, red pen stuff and take away AD just to add it in again, just for style points. BC minus AD is, of course, minus 1, which will cancel with this one. The same thing has happened down here. The 1s cancel away. Obviously, you get what I said you get, which is A squared plus AD, and A squared plus D, AD plus D squared at the bottom here, which you can now factorize out from, and factorize out the whole thing, and we'll end up with the answer here. Always making sure that you make big notes of things that step questions lead you towards, because otherwise questions get very difficult if you don't. Hence, prove A plus D is minus 1. So, okay, we've just done this step, so this is where I'm going to start. Again, we didn't just work this out for fun. It's going to be hence. We're going to use it. I decided to times everything by S. And the reason I did that was because S cubed, all the way up at the top here, is I. So I can replace that with an I. If I add S to both sides, I basically have this written down. It's there. And then I plus S is just, this with ones extra in the leading diagonal. So that's just this here. And if you multiply this out, when you're multiplying, this does affect every single term. It's not like adding, right? We can now clearly see that if this thing is to be equal to this thing, then a plus d all squared must be 1. Otherwise, these two diagonals don't work. So that's fine. It's not this. This, of course, implies a plus d is either plus or minus 1. And you could probably do some pretty tricky algebra to try and figure out which one it is from here. But actually, it's better to just go back to this top here on this line. And instead of doing what I just did, keep this in mind because it is going to be helpful. But from here, what we can do is we can say, okay, well, s squared is this. So let's resubstitute this business back in to get this here. Let's expand that out to get this. And now I already know a plus d all squared is 1. So therefore, this thing is just s minus s, which goes away. And now I'm going to need a plus d to be minus 1 to make I equal I. So that's going to be the ending of that, I think, all done. And the last part of this question, so s is a 2 by 2, show if s cubed is I. So that's very similar to what we had last time, except last time it said s cubed equals I, but s isn't I, specifically. And then we showed all these things on the basis that s wasn't I itself. Now, this doesn't rule that out, so maybe we should rule that out ourselves, right? Because it also says s plus I represents rotation. Now, if s was I, then I plus I is just this. And that's not a rotation, right? This is an enlargement, is it not? Something like that. So therefore, s isn't I. And because s isn't I, that means 1, 2, 3, all rules apply. Fantastic. So we've got all that to carry forward with us now. So now we can deal with this stuff, and that's all good. So now s plus I represents rotation. So let's just call s, of course, a, b, c, d. Otherwise, sure. So we're going to have to use s as that. So s plus I is this business. And now that represents a rotation, apparently. So therefore, it's something like this. So therefore, a plus 1 is cos theta, and also d plus 1 must be cos theta. In a rotation, these two figures are the same. So a plus 1 must equal d plus 1, but a plus d equals minus 1. So therefore, a and d must be minus a half each to make that make any sense. And also, b and c must be the negatives of each other, also, to make this a rotation, which we know that it is, because they're telling us it is. So therefore, s, if a and d are minus a half each, not s plus I, but just s, is minus half, and then the b minus b, it probably doesn't matter which way around you write that, like so. Now, how do we work out b? It hasn't specifically asked us to, but I think we probably should. How do we work out b? Well, we've used this bad boy. We haven't used this, but we haven't used this either, and this is more important. Det s is 1. So therefore, this times this minus this times this is 1, which will give us this figure. And so b is plus minus root 3 over 2, clearly. And yeah, we can put those in. And now what rotation does this matrix represent? Well, we need cos theta to be minus a half. So therefore, this is, well, no, we did this one before. It's 120 and 240. Yeah, it's what we did before. And then you can check the signs are consistent and it works. And that's the whole question. Thanks for watching.